each of 5 through 21, prove each statement that is true and find a counterexample for each statement that is false. Assume all sets are subsets of a universal set U. For all sets A, B, and C, if A is a subset of C and B is a subset of C, then A union B is a subset of C. Now, in the last few videos, I've been using Venn diagrams as a way of seeing if these statements are true or false. Let's see how we could use a Venn diagram to determine whether or not this is true or false visually. So first it says A is a subset of C. This is a premise here. So if A is a subset of C, then that means there is no A that's outside of C. The only A here is the part that's inside of C. So we can imagine deleting this part of the Venn diagram. But also B is a subset of C. So that means we can delete all of this part of this Venn diagram because there are no elements that are outside of C that are still in B. So really B is right here. But then it says A union B, which would at this point just represent this portion right here, is a subset of C. And sure enough, this region right here is inside of C. So this looks to be like a true statement. But let's prove that this is a true statement. So we're going to assume A is a subset of C and B is a subset of C. We want to show A union B is a subset of C. This is the goal here. And to show that something is a subset, we can use the element proof, which means we start with an element that's arbitrary from the first set and show that even though it's arbitrary, it must therefore be in the second set. So let's let X be an element of A union B. By definition of union, this means that X is an element of A or X is an element of B. Now we've come to an or statement in our proof, so we can break this up into cases. Either X is an element of A or X is an element of B. Case 1, X is an element of A. Now we have assumed that A is a subset of C. So since X is an element of A and A is a subset of C, then by definition of subset, that means X is an element of C. And that's what we wanted to show. We ultimately wanted to show that X, which was originally an element of this first set, is also an element of C. Now let's move on to case 2. Case 2 is the claim that X is an element of B. This case is going to look just like case 1, but instead of utilizing the fact that A is a subset of C, we're going to utilize the fact that B is a subset of C. And so by definition of a subset, this means that X is an element of C. Either way, in case 1 and case 2, X is an element of C. No matter what, whenever X is an element of A union B, then therefore X must be an element of C, which proves that A union B is a subset of C. And that proves this statement that if A is a subset of C and B is a subset of C, then A union B is a subset of C. Thanks everyone, and I'll see you in the next video.